This is one of a number of videos on the topic of simultaneous equations. When we think of simultaneous equations, we should think of two or more equations with two or more variables that we need to discover. We need to find out what their values are. So it's not a single equation, this is two or more. Normally, for calculation purposes, we have two, but there's no reason why we shouldn't have three and three variables. It just means the computation is a lot more difficult. So we tend to go with two, and we accept that if there was more variables, we'd have more equations. We'd need more equations. We also have to have the equations unique, and we'll talk about that in the course of this video. So let's run through this one and see what we can get out of it. It's one of a series, as I said. We've made several videos on simultaneous equations. But let's, for a start, let's look at 2x plus 4y equals 6. Now here we've got two variables. We have a single equation. So we have two variables, x and y, and you'll note we've only got one equation. Therefore, we can't solve it. We can solve for x in terms of y, or we can solve for y in terms of x, but we can't find a solution to it. It's one in terms of the other, x in terms of y. We can say 2x equals 6 minus 4y. So the value of x depends on y. So what we need is, we need two variables and two equations. So here, if we were trying to solve that, like I said, we'd have 2x equals 6 minus 4y. Take the 4y from here and take it off over here. So you got that. And that means x is equal to 3 divided by 2y. But that's not a solution. That's just another equation. So if we have two equations and two variables, we can solve it. If we have that, we can solve it. But please note, when we talk about two equations, they must be different. They can't be duplicates of each other. They can't be just one equation times two, which gives us the second equation. That, in a sense, is the same equation. It was just multiplied everything by 2. So the equations must be different. If the equations are different and linear, of course, then we can solve it. So here, for example, we've got 2x plus 4y equals 6. Now, if I double this equation, I got 2x, well, it becomes 4x, 4y becomes 8y, and 6 becomes 12. That's the same equation. They're the same, because we can reduce this one back to this one by simply dividing by 2. So there must be different equations. Now here we have two equations, so we can operate on these. Subtract equation 1 from equation 2. So this is equation 1. Subtract this from this. So we have 3x minus 2x. So 3x plus 4 equals 6. Have I got that the wrong way around? No, I haven't. Or have I? 3x plus 4y equals 8. Sorry, that's equation 2. And we've got 2x plus 4y equals 6. Oh, that's correct. Okay, I've just written it down here. So now if I subtract, take 2x away from 3x, I got x. Take 4y away from 4y, I got nothing. So I've got x equals 8 minus 6, which is 2. So I got the value of x straight away, just by subtracting one equation from 2. Now if I know x equals 2, I can substitute that into one of the equations. So I can take equation 1 here. Now I know x is equal to 2, so 2 times 2 is 4, and I've got 4 plus 4y equals 6. So there's 4 plus 4y equals 6. That's 4. So take 4 from the left hand side over here. So subtract that there, it just cancels out, and subtract it over here. So now I've got 4y equals 6 minus 4. 6 minus 4 is just 2. So I've got 4y equals 2, divide by 4, giving y on its own, divide the 2 by 4, so I get a half. 2 over 4 is a half. So I've solved it. I've set out with this set of different equations. They're not, as I said, they're not just multiplied by some one figure. It's not double, for example, like the example I gave you earlier. These are different equations, but they're linear. They have 2 variables each, so I can solve these by simply subtracting one from the other to get one of the values and then substituting it in. So with 2 variables, 2 equations and 2 variables, we can solve that. In fact, simultaneous equations can always be solved as long as the number of variables equals the number of equations. We're not going to prove it here. It's sometimes known as the identification problem or identification issue. We need the equations identified. So each equation, in a sense, gives us a solution to one of the variables. So if we have 3 variables, we need 3 equations. If we have 4 equations, 4 variables. You got the idea. Final point. We say the number of equations, we mean number of unique equations. The example I gave you right at the start of this video, where one equation was just a double of the second one. Well, that's not a unique equation. That doesn't help us any. We can't solve with that, because really what we've got is just one equation still. We've got it written down in different ways. So these equations, as I said here, 2x plus 3y equals 4 is the same as 4x plus 6y equals 8. Just multiply by 2, or multiply it by 3 or 4, whatever you want. That equation is not uniquely different to this one, so it can't help us to solve the equation. It has to be different. It can't be just a multiple of the other one. 2x plus 5y equals 26. 3x plus 6y equals 33. We need to get rid of one variable, say x. Now, we can multiply equation 1 by 3. If we multiply it by 3, we could have 2x times 3, which is 6x. Then we've got 5y multiplied by 3, which is 15. And we've got 26 here multiplied by 3, which is 78. So I've just multiplied equation 1 by 3. And the reason why I multiplied it by 3 is because I've got 3x in the second equation. I want to get rid of that. So I've multiplied this by 3. So now if I multiply the second equation by 2, I've got the top one here is the 6x, and multiply the bottom one by 2. So we'd have 6x plus 12y equals 66. So what I've done is I've forced the coefficients here of x to be 6 and 6. And that enables me to get rid of them, because now I can subtract them. Subtract equation 1 from equation 2. Or you could do it the other way around, it doesn't matter. So here we've got 3y equals 12. So you can do it this way. You subtract equation 2 from equation 1. It doesn't matter which way you do it. You just get a minus sign, whichever way. But anyway, the point is, we've got 3y, subtract that, from that, get 3y equals 12. Divide by 3 on the left, divided on the right, so y equals 4. So we know the value of y now. Now it's easy to find the value of x. We can just substitute the value of y into one of these and it'll come out. Now substitute 4 into either of the equations, doesn't matter, 1 or 2, doesn't matter. So we'll say y equals 4. So we have, let's say, 6x Oh, we're going down this route here. We'll take equation 1 here. So we can substitute that. We can substitute it up here as well if we wanted to. Doesn't matter. So we'll substitute in here. So we say 6x, and we've got y equals 4. So 15 times 4 equals 78. So we have 6x plus 60, 15 times 4 equals 78. Take 60 away from the left hand side, take it away from the right hand side, we're left with 18. 6x equals 18, x equals 3. So we've just solved the simultaneous equation. We know what the value of y is, we know what the value of x is. So we've solved these two equations here. We've solved them simultaneously. So we have y equals 4 and x equals 3. So that's how to solve simultaneous equations. And that will conclude this talk. So thank you for watching.